Okay, this is a video to go through question 5 of exercise 5Q from the textbook, which is page 264. All right, so I'll upload these notes as well in case it's not very clear to see. I know I've got a bit of light here. So we're given a kind of water container with an open top, and so it's a cuboid but with an open top, and I'm just going to give the dimensions: height as x, width as y, and the depth as z. We're told that the volume has to be 10. Well, the volume in terms of x, y, and z will just be those three multiplied, and that is 10 meters cubed. So all the units here I'm using are in meters, or meters cubed, or meters squared. So I don't need to worry about changing any of that. So x is in meters, y is in meters. And also the other thing just to mention is that all of these are going to have to be strictly greater than 0, because they're obviously all positive lengths. So I need to try and find a bit of a relation between these things. The first thing I'm going to note, because I've read through the whole question first, is that the width is double the length is double the width. So in my case, 2y is double, y is double z. So rather than even keeping these three in here, I'm just going to, right from the start, I've changed this out and say, okay, instead of z and y, I'm going to have z and 2z. So my volume is now changed. It's x times 2z times y, or 2xz squared is 10. This is actually, by the way, my second run through of this question. So the first time I didn't make these adjustments as early on, and it meant that it got a bit more complicated. So it's easier to make these adjustments. And I'm going to try to get everything in terms of x, because I prefer to work with x. So I can, now that I've got this down to 2 variables, I can actually use this relationship to find z in terms of x as well. So z is going to be 10, or z squared is going to be 10 over 2x. So z is going to be the square root of that. And it's going to be the positive square root, because we've already said that z has to be greater than 0. So I'm going to redraw this with just everything in terms of x. So I've got x as the height. I'm going to leave it like this for now. No, hang on. Why don't I simplify it slightly? Let's make that 5 over x. So that's 5 over x. It's the square root, and this will be 2 lots of root 5 over x. I'll probably split that surd up when it comes to the calculation. All right, so we've got our 3 dimensions in terms of x. And the next bit of information we're given is about the cost. So I know that the base costs $10 per meter squared. So the base will be these two things multiplied together. What was y and z, and then 2z and z, it will be these two. So the base dimensions will be 2, root 5 over x, root 5 over x. And actually this is quite nice to have 2 surds that then will just multiply. That's the size of the base, and then the base cost will be that times 10, because it costs $10. So that's going to be 10 times, well, these will cancel each other out, so I'll get 2 times 5, which is another 10 over x squared. Sorry, not over x squared, over x, because I've got root x times root x, which gives me x. Root 5 times root 5 gives me 5, times 2 is 10. And then this 10 is from the cost. So this base costs 100 over x dollars. Okay, which basically tells me that if the height is 1, the base will cost $100. If the height is 10, the base will cost $10, right? Because the base will be smaller, so it will cost less. So it might look confusing, but it kind of does make sense. Right, now we've got the sides size. So our sides will be, I'll have 2 these sides, which will be x by root 5 over x. So I'll have two of those. That's the 2, that's the height, that's the other bit. And I'll have 2 kind of front and back, if you like. So that's the other side, front and back, which will be x by 2, 5 over x. And I'm going to have 2 of those as well. So 2 times 2x. I'm putting those together as I go, times 5 over x square root. Okay, I'm going to try and simplify that a little bit before I go any further. So I've got 2x of those, and then I've got 2 lots of 2x of those. So in total, I've actually got 3. Sorry, that's like 4, and that's 2. So actually, I've got 6x root 5 over x. And I could simplify this even further by cancelling out the root x at the bottom with a root x at the top. So just to be really clear, I'm going to rewrite x as root x, and I'm going to cancel one of those with the root x at the bottom. So I get 6 times root 5. Oh, let's pop that under there. So this means that my sides cost, because all the sides cost the same, and that's was it $6? I hope it's $6. I'm just trying to remember. So it's 6 times that. It's actually 36 root 5 x, or 36 root 5 x to the power half. Because I know what's coming up, I'm going to be differentiating. So I may as well put it in index form now. Okay. Using these, I'm going to get my total cost. And I'm going to call my total cost C. Total cost, and that's going to be C in terms of x. So that's just my notation. So C in terms of x will just be these two added together. So I've got 100x to the power minus 1 plus 36 root 5 x to the power of a half. To find a minimum or maximum of that, I differentiate. So I want to differentiate with respect to x. So I get minus 100x to the power minus 2 plus 18 root 5 x to the power minus a half. And it's this that I want to set equal to 0 and solve. Okay. So I've got minus 100, and here is where I'm chopping and changing between my notation depending on what I'm doing. So here I'm solving it, I'd rather have it as over x squared than like this. When I'm differentiating, I want it as an index. Okay, plus 18 root 5, then this is going to be over root x. That equals 0. Actually, might have been easier to leave that as a power for a moment. I'm going to multiply everything through by x squared to get rid of the fractions, basically. And I'm going to put, I was going to put 100 over to the other side as well, but let's just do it step by step. Okay, so I get minus 100 plus, 18 root 5, and then if we've got power minus a half, and then x squared, I'm going to get x to the power 3 over 2 is 0. Now I start solving. So take the 100 over, divide by 18 root 5, and then to get x, now this means cubed and then square rooted, right? Power of 3 over 2 means cube it and then square root it. So to undo that, I'm going to square it, and then I'm going to cube root it. Okay, so I've raised this to the power of 2/3, if you like. If this bit's confusing you, you've got to go back and revise your index powers. Okay, this is where I think I'm going to grab a calculator. Unfortunately, my graphical calculator has run out of battery, so I'm going to try and do it with this one. So I've got 100 divided by 18 root 5. I'm going to square that, and then I'm going to cube root it. I get 1.8344. Okay, I'm just going to write, it probably goes on for longer. In fact, it definitely does because it's a surd. But I'm going to write the whole value. Now, does this seem reasonable? If I go back and I think about my different heights, yeah, 1.8 meters kind of seems reasonable. Let's get an estimate for what the base and the, sorry, for the width and the length. So let's remember that this was 2 times root 5 over x, and the other one was just root 5 over x. So I'm going to just kind of get some estimates for that to make sure I'm in the right ballpark. So this is my full answer. I'm going to use it. I'm going to do 5 divided by that answer, and then I'm going to take the square root. So this is roughly 1.65, and then this one is roughly 3.30. Does this seem reasonable? Would this get me an answer that's around 10? Yeah. So I just multiplied those three together. I get 9.8, but that's because I rounded these quite significantly. Okay, so this is just a kind of check that it actually makes sense. So we call that a sense check, right? Okay, so I wasn't actually asked to find these three values. The question asks me to find the minimum cost. So I need to take this number and I need to substitute it into my expression for the cost. So the cost, writing it nicely, was 100 over x plus 36 root 5 over root x. So I'm going to substitute that value into this expression, and that should give me the minimum cost. If the question also asked me for the dimensions, then I'd be finding these three numbers more precisely, okay, to at least 3 significant figures, and making sure that I wasn't rounding along the way. Actually, all I need to do now is put these values in here. The annoying thing is getting this full answer. So really, what I might do is kind of retype this in to get it more precise, to get back to what I had before. This would be easier on a graphical calculator. It's a shame that mine's run out of battery, so let me start again. So there's my number. There is a way that I can put this into the memory, but I always forget how to do that. Don't want to make that mistake. Okay, so let's do 100 divided by that answer. Here you just got to find the best way that works for you. I'm going to type that whole thing out, and then I'm going to go back to my, oh no, hang on. I want to go back, so I want to go back to what I had. How am I going to do that? I want to do this answer divided by 100. No, I'm just going to have to start again. Okay, 36 root 5 divided by square root of 1.834404. Okay, so that's 59.434, which comes out, this actually doesn't seem very correct, to be honest. No, and the reason it doesn't seem correct is because this root should be here, not divided by it. Okay, right, rewind. sorry. So 36 root 5 times root 1.834404027. This is 109.02, and then I'm going to add those two together. To get 163.54. So we're asked to find it to the nearest dollar. So I'd get 164. I'm pretty sure I've looked up the answer, and the answer is actually 164,000. So somewhere I've gone wrong, but I probably have to figure out where that is, because $164 doesn't quite seem right. We'll stop there, see if you guys can figure it out. No, I've just checked the answers and it is 164, so that's good. So I haven't gone wrong.